random because they kind of stick together.
Anyone cooking?
You want to go to one of them?
No. You get your own.
I'll cook you upstairs.
You want to add button to the call?
Okay, well, if I add one of the cookies to this thing, have one each because we can just divide it. Why not? Who's not a 50p and your head weight off?
Yeah.
Well, otherwise we wouldn't have had enough to get that deal.
Make him sound amazing.
You want the bottom half?
So I don't know what you want.
No,
There's already one on.
I want two buttons.
Oh,
Do you
okay.
want a 1.5 litre?
One such a little bit.
Oh, if you want to make one. You want Or actually what I can do is I can divide the actual pizza prices into 4 and then the extra. Yeah. That's that. I don't want chicken.
I want to see what they have. Do you like that party house?
Oh. What do you like?
Yeah, one of them I have to have.
Fun
So one hand and one back still.
Find it on YouTube. Check mine, and Sarah will share one. A little more games.
Because we're going to be bopping on the table.
Yeah.
Okay.
Yeah, they're not nice. They sound nice, but not. They're really not. They're pretty old fashioned.
Yeah, that is nice. Awesome, thank you.
You guys want to eat a
That sounds
liquid?
about right. Yeah.
Do you eat a liquid or do you eat
Oh.
Yeah, no, make it better.
Yeah, that's what I'm doing. Oh, sorry. I didn't know what
I think he's gone to me from the floor.
Hey.
How are you? That is a lot of food.
Either or, like,
Remind me might know like
Bye.
that.
No, that's actually
Oh, yeah. Give them a 10. We're running. Oh, no, I drink totally. We give them just I've given it to the other panels, but not for this panel. So we well, I'm going to give them yes, but if there was... Yes. That's why I put the screen over there. And the mic's working great. Our... Yeah, I think this was ours. I've been using it as a stand. It works better than the chairs. Okay.
from that.
Ruby asked you to. We should have achieved it. But after this. Thank you very much. Oh yeah.
It's actually using Fursuit, but I have tested.
Your bike's hopeful.
You make it lighting pattern?
I used to honeycomb.
I can see the light here. Nope, it's the inside that is, you can see the, I guess the honeycomb. Oh, yeah, totally. Oh. Oh, that's a great ticket. You go to the bar and they give you a hooch. Hooch of choice. No idea what he was. It's nice. Yeah. Okay.
The next one.
Yeah. Yes.
Okay.
Yeah. All right.
Wait, screw that.
My face is here.
Yes.
Oh, I saw you lurking at the back and I'm thinking, I'm blind. I've waved you twice.
Oh, yeah, that was interesting.
Oh wow.
Yeah,
Nice.
No. Yes, she's
Welcome to our Animatronics and Fursuit panel. So, I figured I would start this off by getting a little. My name is El Cora. And this is.
I am Wayne Fox.
How many of you have an idea of what animatronics are? Okay. How many people have heard of Arduino or Raspberry Pi? This little guy here was a project that I started, I think it was MFF 2014. At the time, I didn't really know too much about animatronics or Raspberry Pi or Arduino or any of these new electronic systems. But I had known for many years that I wanted to make a fursuit that would react and respond while I act. And for the longest time, I had not known how to do it because a lot of the technology was so foreign to me. But with the advancements of a lot of our local maker groups, this started to become a real possibility for me. I spent a lot of time researching online what animatronics meant. And I realized it was in some ways very similar, even though it's a form of robotics, to the art that I did. It was a lot like all of the animation classes that I took. It's a lot about, trying to mimic the movements of what something really does in life. Excuse my voice. I think you've had a little bit of experience yourself with the maker community and some electronics.
Yeah, I'm from the Bay Area at the moment. There's a huge maker community there. There was actually just a maker fair happened, I think, 2 weeks ago. And there are so many neat little ideas that people do. Like you said, you're trying to mimic something through cosplay and through technology. Technology plus costume plus art is pretty exciting right now.
So I sat down and I tried to figure out, well, what can I do? I'm a bunny. The ears are really important. So,
Ears are good.
yes, big ears. So, I was trying to figure out how, from a robotics point of view, I would accomplish something like this. So I actually went on YouTube and searched for animatronic show reels. And there were some just stunning examples of how they could accomplish facial movements, and it almost looks like they were trying to tween. And in an animation term, that's basically, you don't just start, stop. There are points in between. Historically, a lot of, like when we talk in like a movie sense, you'd have one actor sitting behind here and he's got like cables and stuff and he's sitting there moving. He's trying to mimic a lot of the movements that, if it's lion, for example, how do you go raw, and he's trying to act out these movements. But with these nifty little boards right here, a lot of people are using like your phone, for example, to trigger certain movements, or they're using sensors like this. They have feedback gloves, which capture, is my hand moving up, is my hand moving down? And this is all fed into a programmed either computer, depending on how fancy you want to get, or just a basic microcontroller, which is what this little Arduino board is. What's that?
I'll fish mine.
Yes. So, how this was applying to my own suit is, I was looking at how a rabbit moves, and honestly, the best resource you can take from is life. So I went and started looking up what are the muscle structures of a rabbit's ear? Well, you have three muscles. You have one that connects to the front of the ear and kind of wraps around the back. That's to make it so that the ears can pivot forward. You have a muscle that comes down from the top and connects at the top of the head so that they can pull the ears up. And then you have one in the back that helps to pull the ears all the way back and rest up against the body. I went through several iterations of this head trying to figure out how to accomplish that look. And I went from a little coupler, I went from, you know, these giant servos, and it just, I realized that some of these were a bit bulky. So I went back to some of these show reels, and I'm like, okay, well, how did some of the other people accomplish some of these tasks? And basically, you have to get very good at hiding things. In my case, I figured, what do I want these ears to do? Well, they need to pivot. So I started with one servo that does that function. Then we had, on our rabbit's ears, two muscles to pull it up and pull it in. And I'm like, well, I can't really do that if I have a pivot motor here without making it look super bulky. And that was my biggest hang-up. I spent months trying different 3D printed designs, and then I realized one of the concepts that was mentioned in some of the show reels and some of the examples, which is basic physics. One of the earlier examples that I had done or messed around with was putting the whole ear on a motor pivot. So instead of like right here, if you guys can see, I don't know. It's got a hinge. But before, this whole ear was just sitting on the servo arm. And I could never get the ear to stay up. Well, it's basic physics. You've got no sort of leverage for the ear. And then I realized, well, let's do a hinge. And then this little servo, it's a high-powered servo, was able to take the remaining load that's from the ear and pull it up. And that's how I accomplished the ears going up and down. So now, you know, I can have it be back and have it fold up or have it go down. So that's essentially the motions that I wanted to get out of a rabbit's ear. One of the other issues that I had run into was, you know, a lot of people were saying, well, some of these servos, they need lots of power. Well, not necessarily. That was when I turned back to the maker groups. And the maker groups are awesome to talk to. You can get in contact with them, you know, in many, many local areas. I mean, they're popping up all over the place in several different countries. And ironically, the Raspberry Pi was actually local to the UK. And I think they have some pretty big maker groups over here.
Yeah, I want to say that Arduino actually came out of Italy, so it's a very European thing.
Yeah. So I realized that, okay, now I've got the ears that can move. Well, how the heck do I act in suit? that's when I realized that I could use flex sensors on the hand. What a flex sensor does, it's essentially a resistor. In an electronics terms, that's a component that restricts the flow of voltage from one side to the other. And there are lots of different variations of resistance, but for the purpose of my suit and this little controller here, all I need to know is how much this little sensor is being flexed. And in doing so, I can use these as triggers. So currently, my hands are set up so that if I fold down, because I have a 4-fingered suit, so if I fold down these ones, I can use this to rotate the ears up and down. And I can use the other finger to pull them back and forth. And this is more of just a prototype to see what I can do with this new thing that I'm building. And I also had this as kind of like a backup plan in case these fail. So I also made it so that this is sound reactive. So in terms of what you can do, really you have to come down with what you want for your idea. And there are a lot of really good online resources. I got most of my stuff through Adafruit. To continue?
The fact that everything is now so much smaller and available pretty much to anybody has made stuff like this really available to all of us as hobbyists. Because before, you either had to know people in special effects to get access, or you had to do very large things that, while they look good on the screen, normally you don't see the guts of most of these animatronic characters that are usually behind the table and then trail like 80 yards of cable to a puppeteering team. Being able to do stuff where we can self-pilot our own costumes around, and now add extra features like animatronics, lights, sound. Like, this is new stuff, and only because it's gotten so small, especially batteries. Tiny batteries and tiny controllers have made so much stuff accessible.
I wanted to open up for some questions, because throughout the con, I've had a lot of people asking me. So if there's anyone that wants to know something specific or how I accomplish something.
In my ears, I would like to know something which could make it look a little bit like a heart or something.
You want a 555 timer.
Why?
It's the cheapest and easiest. It's a little chip. You add one resistor and I think an oil capacitor,
Okay.
and you can make it blink at a certain rate.
No, not like that. It's like if you have a muzzle that's open, like a heart, it's something where it expands. Like a heart.
Oh, with like some kind of like perhaps air in there to inflate a little bag, maybe.
Yeah, something like that.
Yeah.
Because it's actually it's the lungs that sits up there.
Oh, okay.
I actually saw a project that was had very similar properties, and basically what he did was he 3D printed a bladder with a silicone type filament, and basically he had a little motor with a like a 5.5 timer or a little mini controller that basically turned the power on and off. So it would put water or put air in, and then it would suck it out, and then it would put it in, and then suck it out. So
Actually, to anyone that has like sort of those questions on how do I do a physical representation, I've been trying the last 5 minutes to remember, but there is an archive of every mechanical motion that exists to date. It's like an engineering archive, and it will tell you how to make arms and pivots that do certain ranges of motion, certain types of motion. So don't necessarily go out and try to reinvent the wheel every time. A lot of this information is out there. Go on Google, do a bit of research, and find if there's maybe methods of doing bladder, like air bladders or water bladders, that will sort of accomplish the look that you're going.
And I mean, you could even go something simple, just a little hand squeeze. Any more questions?
Yes. I've just built a, basically between a single axis ear control servo using a Fursuit S2003 servo and 555 timer chip circuit. And the bugger sort of sorting out. I was using a slide resistor on a palm, basically a slide pot on a palm thing. Which I think those flex resistors would work better. But at one end, once it switches off, at the other end, it continues buzzing when I reach the end of the range of motion. And how can I stop that?
I have actually run into this issue. One of the things about servos is they're all slightly different. For example, these blue little micro servos, these are a range of 0 to 90. But whenever I try and write the timings to get it to 0, it actually shuts off. I actually found that if you cut it 5 degrees before the minimum or 5 degrees before the maximum, then it gets rid of that buzzing.
Right. So you actually want the slide range cut off so it doesn't reach. The ones I've got have 180 degree. So I want to be able to slide between 5 degrees and 175 degrees, and as long as I do that, it won't buzz.
You'd have to test to make sure that it's your specific servo motor. Because like I said, each motor is slightly different, and it has its little own quirks.
The thing I've noticed is that when you switch the circuit, when you disconnect, that it stops buzzing altogether. So one of the ultimate solutions I've come up with was having, as well having the slide, also having some sort of stopper that switches when it reaches the end of its run. It actually also disconnects the resistor, which will stop the circuit and therefore stop the motor in position, which won't buzz. But this sounds like an easier fix.
Yeah, there are some mechanical limitations to the way motors work. I use stepper motors in some mechanical projects, and they have basically holding torque all the time. They're always on. So they're really loud when they're going. They whine and whine and whine. And it's the same with the servo motors. Some of them will have basic requirements for holding current to keep things where they're at. When they're coming from like planes and stuff, so you can imagine a model airplane in the sky. And you tell that the layer run, all right, stop and stay there. It actually has to power it to hold it there. So if you're at the far range of your motor, you're probably going to get whine off the coils because they're still active. But if you take all the power away, your ear might just go and fall back down.
The one I've got, as long as when it's switched off, it stays in position. But then I'm not particularly stressing it to it. It's got something like 4 kilogram centimeters of torque. So it's more than enough for these bone rubber ears to be using. But talking too much.
To the right people.
Are there any more questions? Things that people would like to specifically know about an animatronic costume?
Yeah.
Oh.
Okay, and then there's 2 we'll get next.
All right.
Have you thought about using model railway servos instead of aeroplane servos?
I haven't looked into a specific type. I just look for the different ratings that suit my need. So if I need 180 with a specific torque, if if a railroad servo meets that requirement, then definitely go for it.
Yeah, it's just a question more about sort of battery life and how you guys sort of handled that, because I've been working on a project for about 2 years now, trying to get my robo-suit together. One of the things I keep coming in sort of trouble with is just trying to get voltage controllers to just not keep crapping out on me. But with the voltage drop, how do you sort of try and combat particularly Arduinos from just sort of dropping out and just disconnecting randomly and stuff like that and just stop processing?
Capacitors.
Just
Capacitors are very good for keeping voltage when you have a really quick sudden change. Servos are really good at causing bad voltage drops.
Firing up Donkey.
Gotcha.
Donkey is fired up. Donkey took 3.5 amp at full glow. Like if he goes to white, he's drawing the most damage he can, and the Arduino goes blah, and turns off. So on the Arduino itself, there's a teeny tiny capacitor, which in the instant of all voltage going away, it just is enough to keep the Arduino happy.
Right.
And the same, each of the arrays, like the cheeks are 1 array each, and the ears are 1 array each, and you do math on how much the total draw per array is, and then put 1 capacitor per each. So these have a 2,000 microfarad capacitor in each cheek, and then there's 5,000 per ear. So just at the moment where you're drawing a lot, like either off a server or your sound reactive lights are pop full brightness, you don't crash your system because the little batteries that are on them, they're just trying their hardest to keep up at this point. And this guy's actually built off a Pro Trinket, which is one of the tiniest little microcontrollers, because I wanted everything in the head, because I didn't want to have to worry about anything other than the contact switches on it. He runs all off magnets and reed switches, which are buried under the head, so I can just touch on certain spots to do different modes.
From a physical point of view, how would the sort of electronics and servos and things actually connected to the base, sort of physically? Because what's the base made of? Does it have to be made specifically with a particular material?
This specific head is made of foam.
Yeah.
I had a lot of trouble trying to get the ears to stay, so what I actually did was I took a big piece of plastic, it was like a plastic sheet, and then I cut out kind of like a base plate, and then I glued it heavily to the base, and then that allowed me to put screws into the base, and then I just 3D printed all of the little holes to kind of just screw it in place.
Another friend in the community, M-Blade, has a suit that has a lot of little individual light pucks in the suit on the back of it, and he had to make sure that it had something sturdy, because if this is like a little tiny LED array, if you have the wires coming off of a suit, they're going to bend right there, and eventually your wires will snap the more you move. So he found that taking about 1,000 popsicle sticks and sewing these inside his costume, it gave him a nice solid place to put the hardware wherever he needed it to be. And then there was a question.
Obviously, every animatronic suit is built slightly differently, but in your case, do all the electronics and servos think there feel particularly invasive when you put it on? I mean, when you put a normal head on, it's just sort of fluff and foam, but when you've got all these electronics and servos going in, does it kind of feel like you're stepping into a machine, or is it all sort of nice and smooth?
That was one of the issues that I ran into with this suit. I had actually stuffed all of the electronics into the back. So, because generally speaking, the back of the head is a nice place to put things, like if you've got a battery for a fan, or it could be whatever it is that you need. In this particular example, well, I tried to put the battery and all of the electronics and wiring, and it does get pretty heavy. This is probably about 10 pounds when you try and put it on. And that was one of the really interesting things about this project, is I had failed several times throughout the entirety of all of this, but I learned something every single time I messed up. For my next projects, I am most definitely going to be offloading the heavier components to like a backpack or like a side pouch, or maybe if the character has a costume, offload some of the components into that costume. And one of the other things that makes this suit so heavy are all of these waterproof connectors. I wanted to be able to have the hand controllers communicate with the head and all of the microcontroller commands with the hands, because these are multicolor LEDs. Whereas for a later project, I can offload all of that by maybe doing Bluetooth communication. So that way I'm not having to worry about these bulky wires coming down my arm. And again, that's the nice thing where all of the technology is going. It's just getting smaller and smaller and smaller, and you can just fit it into different spots.
And wireless is the way to go, because I have spent more hours fixing this donkey just because of broken wires. As you move around, you're not just going to be a statue of the suit. Who wants that? The whole idea is I wanted a character where I didn't need a puppeteer to do the extra animations. That's why I use the contact sensor, so I can just hold the paws to my nose and mimic like I'm blushing, and the cheeks glow pink. So that's like natural motions to simulate the actions that I want. If I touch my ear, I change the color. This doesn't look like anything to anyone that's watching the suit. And now you can have the experience of changing it. But the wiring is always going to be just the nasty part of it. So if you can do wireless between controllers now, it's so much easier. Especially for things where you're using like the hands to do separate motions. It also makes it so that you can repair individual components a lot easier.
Yes.
Because stuff will break. Guess what? It's going to break a lot.
I think I saw
This one.
Should we go here next?
This is rather ambitious, but with eyes, if you want the glow and the pattern to be moving within the eyes, have you ever figured out a way to do that?
Disney used color wheels at one point.
There's a site called Dragon Eyes or something. That's what we screen with the lens.
Yeah, someone has done a dragon suit that it basically has a phone screen in place of the eyes, and it has a pre-programmed program for all the eye movements. And so you've got a thoroughly detailed eye, but essentially it could be programmed to change colours or swell.
Yeah, the teeny tiny OLED screens you can get nowadays are pretty awesome.
Yeah.
I've seen around, someone's actually come up with masks that basically there's a slot that things like Cyborg with a bulky eyepiece or Zombie and there's a pouch there which you can just slot the mobile phone into, and then you download an app onto the mobile phone which displays an eye or something, and so you don't actually need to build it. You just need to, can't remember what the place is called, but I'm sure you can search it.
I was thinking about your butt cramps so you can see through. Because that's the thing, most fursuit eyes, proportions and everything. You need to be able to see through the eyes as they are.
Yeah. I was actually trying to think of a way that I could do that on this suit. I found really, really, really tiny LEDs. I mean, these things were like
RGB, yeah.
These ones weren't RGB, but they were blue because I only wanted 2 pins. And what I was going to do was make like a basic grid along the mesh, and then do very, very thin wiring across there. But I ultimately decided not to because that's an area where a lot of moisture is going to go. And that becomes the problem. If you're gonna see through the buckram, you're now gonna be covering up the silicone. So, honestly, I think if you wanna try and do something special with the eyes, the new OLED technologies that they're coming with, and maybe just like a camera on the head and a little screen behind, might be something more that you want to toy around with. That might be a much better way to go about it.
A nice little segue into my questions here is, if you're going to be in a suit is a very hot and warm and damp place. Guess what electronics don't like? Very hot and warm and damp places. So do think about this when you're building them. You're going to have to put your battery in a spot where you're not going to sweat all over it. Your hardware has to sit in a spot where it's going to be more or less safe. Because of the sizes of these pro trinkets, I could just stuff him, this is an Altoids tin, has all of his hardware in one little spot, very in the main, way away from me and my sweaty little head, and the donkey's okay. But the wires that run on the base of the head, that's where there's a lot of problems, because the base of the head gets wet. So you want to make sure anything you put in, you seal it well. Especially if you've got stuff buried inside the head that you're never going to be able to get to again. This is all lifetime placement stuff. When these LEDs burn out, there's no way to get to them anymore.
It's not just sweat you'd have to worry about, it's rain, it depends if it starts chucking it out.
Yeah, if you go to Burning Man and you're in the desert and that dust gets into everything and shorts things out in this most bizarre way possible.
And another...
Yep. Yeah, any exposed metal will just start to corrode.
Yeah, especially copper. I just want to make one more note. One thing that I definitely recommend are these USB battery packs. A lot of these USB battery packs come with fault protection, so if they get wet, you don't get shocked and the battery doesn't, explode. That's very, very good when you're wearing a suit. Acid on. Okay, so.
This one's been really good.
Yes.
These battery packs, they prevent shortage, but they do not prevent leakage. How do you secure them so if they happen to leak, you don't get acid over your body?
Good question. I've actually seen online they've got these really cool fireproof bags.
Yeah,
you can slip them in there and then zip tie the top. And if you're really concerned about battery acid getting on you, those bags generally do a good job. Yes.
Yeah.
Yes. Battery bags, especially if you go with anything lipo, like RC control, the 12-volt lipos. Those things, if they go below their critical voltage, have a big risk of exploding and bubbling and starting bad things.
Also, voltmeter inside there, you can attach with an alarm, it's really good.
Yes.
The screamer alarms, if you're using lipo, the alarm should go off to let you know you have to turn your head off or whatever you're using. Prevent battery damage.
Also, the problem with lipos, they self-oxidize, so they will not get put out by extinguishers or any fire suppressors.
Yeah. Do not get them wet either. You will burn.
Sound like gremlins? Yeah.
Let's go shooting after midnight.
Yeah, switch them off after midnight.
My paradise do that.
And I really wanted the tail to actually move on its own motion without any puppeteering or anything like that. What would you suggest to do that with exactly?
Yeah. I would actually recommend, I thought about this for a long time, for my own suit. What I wanted to do was I put like a big disc up at the top, and then basically, use some sort of armature through the whole thing.
Okay.
And you run a line from the top of the disc through little discs throughout the tail, and then connect it at the end. And then you stick the disc on a servo. And then all you have to do from there is sensors either on your feet or maybe just, it depending on how your body moves.
Yeah, it's going to be a fursuit anyway, so yeah, it's going to be heavily carried as well, because you can instruct these skeletal parts as well, skeletal legs as well, so it's quite a lot to do.
One thing that I found helpful to do when I'm trying to figure out how I react naturally is I look at myself in a mirror. I see how I walk, and then I figure out, well, what changes throughout my walk, and then how can I use that to, you know, do some sort of electronical.
Yeah, to trigger the sense.
Yeah.
To come back into the
Yeah.
cell, to actually notice what happened, so it's more.
Actually, I like the idea of putting a foot sensor because basically you want the motion when you're moving.
Yeah.
You can also put like an accelerometer somewhere in the head to sense if you are actually moving. That way you can stop the tail if you stop, or whatever you want to do.
That's actually a really good idea, thank you.
Have a look on a company called the Moving Tail Company. They already make them.
Or Wolftronics.
All them.
Well, honestly, I would keep it simple. Just do 2 sensors, because then you can do, if one is up, then you know which one to go against, and if both are down.
And if you build it yourself, I suppose that you know if anything goes wrong, then you know how to fix it. Whereas if it's like a up-to-date one or something that's been done and something blows on it, you won't know where to start, or you might have to buy a brand new one, maybe.
Gentlemen.
Yeah, I just wondered, it's a bit out there now, but the use of sort of the brainwave readers for controlling any parts of face or tail or anything like that?
Yes. You know, I've actually seen a lot of people integrating the Nico Mimi ears into their costume already. And if you can get a good reading off of them, then I've seen people do some amazing stuff. But they're also, it's kind of an automated process. So it really depends on what it is you want. If you're okay with it more just kind of doing their own thing, then the Nico Mimi ears are probably a good option. But if you want something a little bit more custom, I've actually seen a new technology come out is muscle readers. So basically you've got little pads that you can stick on your skin, and it takes a little bit of training, but you can trigger code inside a microcontroller from these different sensors. So you could smile and it would trigger a servo on the face, for example. You could do the same thing for the ears.
That's actually exactly what I was just going to ask you about. There's a project I've been working on that I've not really had much success with. It's a retractable claws. What my idea was, is it senses when you tense the muscle with the big one at the front there, and that makes the claws come out.
You know,
but I was using like a clamp, it's on QTC, but not had much success with it. So.
if you're just looking to do it with your fingers moving, I'd just go with the flex sensors.
The idea was you should be able to move fingers independently, but when you actually tense the hand, that's when the claws come out.
You're going to have to get really good at muscle control at that point to pretty much train yourself to flex one part of your hand while doing stuff with the other. I mean, it's possible.
I see a montage coming on.
I think I saw someone up front who had their hand up for a while.
It's about batteries. I've seen some really nasty things happen with batteries. And I even have experienced some stuff when I built props and stuff like that. Batteries, even normal small batteries, if they're connected wrong in some way, they can go apeshit. For example, I've seen a normal AA battery jump over the table, like a Mexican bean. And that time I someone jumped out of the window, literally.
Well, That's where a little bit of electronic engineering comes into play. I mean, there are a lot of really good tutorials online. I use a website called Adafruit, and if you're worried about, I should say, you should use diodes in your circuits if you're concerned about that.
Some LEDs and stuff like that. I normally use Christmas things.
Well, you can still use a diode from your battery to your whatever it is you're trying to power. And a diode can be anything from an LED.
Yeah.
It's a type of diode.
Yeah.
It could be an IR sender and receiver. Or the more common ones in circuits are flow control. So basically the voltage can only go in one direction. So if you accidentally put it on backwards, it does nothing.
Yeah.
So you can't short the battery out that way.
It was something like, I think, accidentally hit some of the wall to the panel, and that made it spark between them. And that made that battery jump out of the back of the box.
We'll also give a little piece of advice when you're crafting, working on your stuff. Do unplug it. Don't work on live circuits.
Yes.
You'll be unhappy.
Throughout all of this experience, I've actually found that if you work with 5 volts, it's a lot safer. And a lot of these new circuits, I mean, everything you see here runs off of 5 volts. This battery does 5 volts with 4 amps per port. Now, I don't use 4 amps per port, but this battery can handle anything this dishes out. I saw a panel last year where someone was using 12 volts on their suit, and they had issues of some of the circuits sparking.
Isn't that basically like a car battery?
No, they were using just a 12 volt RC battery. And you know, I got around that. I mean, 5 volts do tend to spark and get hot, but not as much as a 12 volt circuit. So if that is definitely a concern for you, I mean, playing around with 5 volts is a lot more safe.
And if you're not actually getting into the servos, which are more the high torque end of the spectrum here, you can run most of the NeoPixel LEDs and the controllers on 3 volts. So you can just get like 2 or 3 AA's, which is totally benign and safe, and run it at a very low power consumption. It's when you get into the requirements of motors and things, we probably need a couple more amps, a couple more volts.
Just don't buy Panasonic batteries. They tend to run out really quickly or don't work at all.
And it depends on your runtime. Like, I can't be in the donkey for more than half an hour to an hour before I overheat, so realistically, why am I worried about a 5-hour battery that long? When I go back and I change out, I just have a little pile of the tiny little, like, 300 milliamp hour batteries, or 3,000, I should say.
If you use only 5 volts to power the servos, be aware that there are some digital servos that have this strange behavior if the voltage drops under 5 volts. They return to the 0 position. And so when you install the servo, you have to make sure that the 0 position is something that can be reached. Otherwise, you can destroy your servo.
And for some of the voltage issues, for like these little blue ones, high torque, I was running into issues with that, and a capacitor actually helped with that.
I had issues with the donkey when it would go to full white mode under their like super sound hit white. Basically, the circuitry would draw too much power, and the Arduino, electronics are like dealing with water in a lot of ways. Like, it will find a way. And it basically went back through one of the data channels, through the chip, and said, give me 5 volts. And I said, okay, I'm going to give you 5 volts off this other I.O. pin. And so it basically said, I need power, and sucked it through the circuitry because it needed it. It'll just basically find the path of least resistance. It's all you're really doing. So sometimes if you get into the modes where it draws a little power and everything goes haywire, you might need another little bit of protection circuitry in there so it can't try to scum power through your chipsets.
Yes.
Yeah, you was talking about the hand controllers and with the sensors in the feet and stuff like that. I was looking at doing something similar, but I was wondering how much it would interfere with actual performance in the suit. Like if you go to pick something up and the ears start moving in response, things like that.
One of the things that I went through was just trying to figure out what my motions are. What are some of the things, what are my tendencies? When I move, you know, how do my hands move? When I go to touch my face, or I go to say hi, or shake someone's hand, what do I do? Because, you know, everyone has slightly different things. And once you identify what those are, then it really becomes a problem solving. How can I teach myself to do a trigger for this action? Or how can I work around not triggering something for the different actions? For me, for the ears, for example, you know, I have one that does rotate and I have one that does tilt. Well, I don't want my ears to be rotating and tilting while I'm, you know, moving my hands. So I actually do this. So this is my trigger to activate these two fingers. It could be something as simple as you've got your hand down on your hip, maybe. You've got your little magnet and a hall sensor on your hip. And then that activates maybe some hand movements to start triggering different things on your suit. And some of the more natural things, like maybe putting your hand on your face. You can just put a hall sensor there with your paw. Like I said, it's all about trying to figure out what you do, how you act in suit.
Yeah, and then like you mentioned, coming down to it, it'll be your pantomime, and then like, stand in front of the mirror and watch your motions. Does this look good, or does it look like I'm fussing with my fingers too much? And then maybe figure out how else to like hide the magic so no one can see what you're doing. Because that's the thing, like if someone is staring at the glorious wibbly and funky ears, they're probably not going to pay attention to your left hand down by your thigh doing something to trigger something else. So distraction is your friend.
Do you get a source for these muscle sensors you're on about? Because that's something I've come across. Since you mentioned it, it's really interesting. One of the other applications I was thinking of others that can move their ears. It would be, you know, excellent to sense the ear movements and use the ears.
You would have to figure out where your muscles are. Oh, I'm sorry.
Just you know,
the muscle sensors that I saw were on sale at a website called Adafruit. It's ADA and then fruit.com. But you can also search for MioWare. I believe it's spelled M-I-O and then W-E-A-R. Yes.
I have a question about tactiles. So, like, if someone is like tossing between your ears, how could you possibly have a sensor there to trigger ear movement?
You could do that with flex sensors. You know, put it on the outside of maybe your fur. If it depends on how you have your hair. If you want just like, if you've got like strands of hair, you could detect movement by watching them move back and forth. You have to keep in mind though that these can only flex in one direction. So these pick up a value by flexing this way, but they won't do anything if you flex it the other direction. So
you could in theory use them as pressure sensors.
You can also do buttons, if you want to do like.
You were to take a strip, several strips of those and run them like across the top of your head, and when someone does like something like that, the ears would like flatten. Because the depression would cause a curve.
You could also use just a capacitive sensor. So as soon as like a person with a meat hand touches it, it would trigger the thing.
It might.
Well, okay, we're a wet, sweaty fursuit pod.
Yeah, you'd have to have a little bit of moisture there if it were a fursuit.
Actually, it would be a much better idea to switch all the powers to the servo off as soon as somebody gets near them. I had one very expensive animatronic suit destroyed because somebody saw this moving ears and grabbed them with both hands and moved them the other side direction.
Oh yeah, force feedback.
Yes, and not force feedback.
Using force feedback,
yes.
you would have it registered that it's getting force feedback, and then it would turn on.
Servos don't do that.
Some of them do.
Yeah.
Some of them do have an analog feedback.
Yeah.
But there's a much simpler, non-electronic way to help combat this.
I did.
It's called a handler.
Yeah.
That didn't work. The handler was there directly besides me.
Do realize, as you start making fancy things like this, you are inviting it to break, because this is not sturdy. The ears on the donkey, I am terrified that I'm going to break constantly. So you're making something that's delicate. So the environment you're putting it in, realize where you're going to be at. You can't control everyone. So yeah, unfortunately, someone's going to come up and mess with your ears.
So it might be a good idea to keep it relatively cheap, but not cheap. That, you know, so it's cheap and nasty that it'll fail.
And if you can make it so that you can get to the hardware that may have breakage points, like here I can see that I can get to the servos to fix them if something goes haywire.
You can get breakout clutches.
I specifically built this so that you can take it all apart, put in a replacement part, which, by the way, bringing replacement parts for your animatronic suit is vital.
Yeah. Yeah, I've soldered together 3 people's simple little light up eyes so far because wire has been breaking over the top.
Yep. And speaking of wires, you're gonna have lots of solder points, so make sure that everything is shrink wrapped and shrink wrapped tight, because water will travel down the wires, down the sleeves. I mean, someone asked me to repair a suit that was just simple LEDs and, you know, some resistors and a battery. And when I started taking it apart, I started stripping things away more and more. And I'm like, these wires are green. That's not good. All it took was a little bit of moisture somewhere down the line, and it just traveled all the way down and damaged the whole thing. So if you're going to be doing wiring, make sure everything is absolutely sealed in every way.
Yeah, I cheaped out of it and I was using a bunch of old USB cables because I have a lot of those at home. Turns out the wiring inside those is not really that great. So I would say go to the hobby stores. Hobby King is one of my favorite for that. And they have silicone sheath wire. It's really durable. It can take a lot of flexing and punishment. And spending the extra like $20 on wiring, in hindsight, would be worth my time because there's been a lot of times where I wish I would have done that.
It's really thin and it's weighted for about an hour.
So you can literally say it was a kick to the ass.
Thank you, Matt.
We got about 5 minutes. If anyone has any more questions, I think we'll take some last questions. And if you want to come up here and look at this and toy around with it, please do. So, any last questions?
You said to be punching pie.
We lied.
It is like cake.
Cake is a lie.
Or
Cake is a
dead.
lie.
Cake is a lie.
No, cake is Dutch.
This is a triumph.
Vicky has given us the nod. Thank you.
I guess it's the touch and look time. Ah, okay.
Touchy-feely, the heady thingy.
Thank you so much, mighty fox, and I'll pour our lovely guests on of this.